Hello and welcome to this presentation about how deep forest can be used to monitor biodiversity and invasive species in MECA's conservation area. So MECA had a discussion with deep forest at a technical level. And so these are the key takeaways from that discussion. First, using DeepForest, the DeepForest technical products, MECA can monitor its conservation areas. Uh, DeepForest products specifically focus on forest health. Um, DeepForest is optimized for Japanese forests, and this is why DeepForest wants MECA's drone data because it would like to expand the products that it develops so that it applies to other areas of the world, such as where MECA's conservation area is located in the eastern seaboard of North America. Deep forest is not optimized for wetlands. It is not optimized for identification of human-made objects, such as trails or lookouts, or water, sanitation, and hygiene wash facilities. Deep forest products cannot identify animals using images or sounds from on-the-ground sensors. And in order to fill that gap, other geospatial software, such as QGIS and ArcGIS, will need to be used to fill the gap that the deep forest products cannot fill, but is still a requirement for MECA's conservation and biodiversity and invasive species monitoring. So it is in the interest of both Deep Forest and MECA to conduct a drone operation trial run. You can call it a pre-pilot drone operational trial run before drones are deployed for the pilot. DeepForest has published specific drone operation requirements to maximize the use of its products. So in the phase one of this pre-pilot drone operation trial run, the drone is tested in a simple forested setting, the drone that MECA will be using during the pilot phase. So I and the drone operator will go to a park and capture forested imagery that will be processed by DFBird and DFScanner, and this is a simple trial run. And it will be using, this simple trial run will be using the specifications published by DeepForest. In the second phase, the test drone will be flown over the Mount Echo summit. A sub-phase, phase 2.1, sees the drone-based remote sensing collection. The drone operator flies a drone over the summit of Mount Echo using the recommended measurement specifications published by DeepForest. The data is then captured. The data captured by the drone is processed by DFBird, and then DFScanner is used to identify the tree species types in the area around Mount Echo. In phase 2.2, human monitors are deployed to Mount Echo, and these human monitors uses the DF Walker product, which can be installed on smartphones to visually verify tree species identified by the DF scanner product. And at this point, MECA will also test a methodology for sampling trees for verification of the tree species identified by DF scanner. And manual measurements are taken that cannot be remotely sensed, such as the tree trunk thickness of specific trees in the sampling area. In phase 2.3, biodiversity invasive species analysis takes place. And this is where the human verified imagery, such as the MSI and LiDAR data processed by DF Scanner, are given to MECA partners who are biodiversity and invasive species experts for invasive tree species identification. So essentially, part of this process, which uses drone data, which uses MECA drone data, involves partnering with experts in biodiversity and invasive species management. And lastly, there is what's called a third-party analysis. And this is the use of other products such as QGIS and ArcGIS to conduct analysis that's not available in the DF products, such as wetlands analysis, the identification of human-made objects, and hazards monitoring.